Static class methods in Python. Before we conclude our section on class methods in Python, we need to know that there is one more type of method that may be defined within a class. We call them static methods. Static methods are defined within the scope of the class but are not tied to or bound to the class, nor any instance of the class. Static methods do not receive the compulsory parameter when defining class methods, the CLS parameter, nor do they receive the compulsory parameter when defining instance methods, the self parameter. Logically speaking, static methods are the same as freestanding functions but are defined within a class. They are defined within the class for convenience purposes or to provide a way for us to group similar functions together. A static method in Python is a method that is decorated with the @static method decorator. So let us assume that we have a simple template of a book class data type as follows. Class book, create a book object in Python, define init, self, parameter title, parameter author, parameter pages. Self.title is equal to parameter title, self.author is equal to parameter author, self.pages is equal to parameter pages. So we will proceed to define a static function. A static function is named such because it does not interfere with the processing of individual class objects, nor does it affect the class behavior. It is used to perform static operations, and static operations will provide us with a static output. So we will define a method called static method in Python. Going by the discussion we have had about static methods thus far, we will first select a spot within our class but outside a method in which to define this static method. Thereafter, we place the @static method decorator. Remember, the decorator must come before method declaration. So we do so as follows. Notice, in the above code image, we have used the @static method decorator. Now we may define our static method. And remember that a static method does not require us to pass in any compulsory parameters. This is why we mentioned that a static method is like a freestanding function in Python. So we proceed to define a function named static method as follows. Notice we have used the def keyword followed by the function name and a pair of parentheses. In a static method, however, there are no compulsory arguments to pass in. This static method we have defined will simply print out a single line of text. Now, we will attempt to call this function to verify if it works in our program. Static methods are invoked via the name of the class they are defined in and using dot notation. Our static method will be called as follows. Book.staticMethod, and output will show as follows. This is a static method in a Python class. Nice. Our script works well. And really, that is all you need to know about static methods in Python. Now, our next topic will be about a topic called class inheritance in Python. It is interesting and falls into the advanced topics of Python. Advanced OOP principles. As you know, this tutorial has been focusing on the concept of object-oriented programming in the Python programming language. We understand that any programming which allows for real-world entities to be modeled using code supports the object-oriented programming paradigm. Now, what we did not mention in the beginning of the lesson, which now is the perfect time to mention, is that the object orientation programming paradigm itself has four main concepts on which it is based. These four principles are seen on the next slide. Please note that for now, we will only be listing these principles in name. We will not be discussing all of them in depth. The four principles upon which object-oriented programming is based are: Number one, encapsulation. Number two, abstraction. Number three, polymorphism. Number four, inheritance. We will be discussing the principle of inheritance in detail. Class inheritance in Python. The main reason why we discussed classes, methods, and other object-oriented programming topics before talking about the four main OOP principles is because the four main OOP principles are based on classes and methods. So essentially, this topic is called class inheritance. And inheritance, as we have just learned, is one of the principles of object-oriented programming. So, from what we have learned thus far, OOP heavily makes use of classes. So at face value, we can tell that the principle of class inheritance deals with classes inheriting something from another class. But what exactly is inherited? Well, the principle of inheritance is a core principle of OOP, which states that one class will be allowed to inherit data and or behavior from another class, and this is one of the key ways in which reuse is enabled within classes in Python. What is class inheritance in Python? Class inheritance in Python allows for features, behaviors, and methods that are defined in one class to be inherited and reused in the definition of another class. Before we move further on this, I would like to give you perspective of this concept using a very simple example. You see, human beings, us, me and you, in biology, there is a very large scale classification tree that has the ability to classify creatures according to their behavior, features, etc. And I am not simply talking about the classification of male and female. I am referring to all the branches of apes, primates, and other early human like beings. A simplified diagram of this large taxonomy classification tree looks like this. Essentially, what I am trying to get at is this. Looking at the diagram on the previous slide, each one of those levels of evolution is actually a class. Homo sapiens is one of hundreds of species that exist on the tree. Animals is one of many kingdoms that exist. Now, every time a human being object is born, it would be ridiculous to draw up a completely new tree which contains that exact same information. For example, if 10 people were born, we would have 10 diagrams for 10 people, and for 10 monkeys that were born, we would have 10 diagrams for that too. But the diagram between human and monkey would not be 100% different because human evolved from ape. Therefore, there would be one or two minor changes in the classification as the branches narrowed down. This is what I am trying to get at. Every time a person is born, they automatically inherit all the functionality and behavior and methods and general characteristics that are associated with a human being according to the evolution tree. The key word here is inherit. This is the exact same way in which inheritance works with classes in the Python programming language. For example, we can have two classes, person and employee. These two are very similar yet differ in terms of behavior, methods, features, characteristics. Because a person class, for example, may have the attributes name and age. A behavior that a person may have is birthday. The employee class will also have a name and age attribute as well. Employees will also have a birthday behavior method, but the employee class may also have another additional field attribute such as employee ID, which a standard person class does not have. The employee may also have another behavior method such as calculate total pay. So, if we were told to define create a person class data type in Python with the attributes name and age and a behavior called birthday, which prints the current age out to the screen and adds 1 to the age to increment it, because When we have a birthday, age in years increases by 1. We would attempt to do something as follows. Let us assume we were told to create a new employee class in Python with the attributes name and age and employee ID. This employee class will also have a birthday behavior method along with a calculate total pay behavior. The birthday method will be the same as that of the person class. The calculate total pay method will require two pieces of information to be passed in as arguments, the number of hours worked and the pay per hour. So, using the above guidance, we would create an employee class data type in Python as follows. And this effectively creates an employee class in Python. Looking at our person and employee class, however, we see that there is a lot of code that is repeated due to those two class objects being similar, since they have very similar attributes and very similar behavior. Our approach involved us creating two separate classes, one for person and another for employee, and we have duplicated the definition, creation of name, age, attributes, and birthday method in the employee class. We simply cut and paste the code in the employee class from the person class. This technique works, but once again, we look at the most important factor, feasibility and convenience and efficiency. This approach was none of these. The general rule of thumb in software development and software design is that it is best practice is something that has been defined, can be reused if a similar design is required at a later stage. This is where the concept of inheritance will be of use to us in Python. Inheritance will allow us to reuse code from one class into another without explicitly coding two or more of the same things. From an object-oriented view, diagrammatically speaking, what we aim to achieve is the following. Class person, person name, person age, birthday. Class employee, employee ID, calculate total pay. On the previous slide, we are viewing a simple object-oriented diagram which tells us that we have two classes, person and employee. There is a person class, which is one unique entity, class, and there is an employee class, which is another unique entity. There is an arrow drawn from the employee class to the person class. This tells us that the employee class has all the features and functionality of the person class, and it has the additional features that show its own box which the person class does not have. It is important to note that the diagram on the previous slide depicts the principle of inheritance and the logic that lies within this core OOP principle. Therefore, when there is full construction of the employee class, there will be in fact three attributes and two methods altogether. This is because of inheritance. With regards to the principle of inheritance, the main class is often referred to as the superclass or parent class or base class or main class. The superclass is the class that needs to be created first before inheritance can occur. In our case, person is the superclass, base class. Those classes that extend on the functionality of the parent class is termed the child class or subclass. When a subclass is inheriting features from the superclass, we have a syntax to follow in Python which denotes or tells us that the principle of inheritance will apply. The general syntax for inheritance in Python. In Python, after the subclass has been created, we need to specify, after the name of the class, the name of the superclass, parent class, from which this subclass will inherit functionality. We need to provide the name of the superclass after the name of the subclass and within a pair of parentheses. So the general inheritance syntax in Python will look similar to this. Now that we know about inheritance in Python, let us redesign the employee class to make it inherit functionality from the person class. We are starting afresh with the employee class, so we will use what we have learned thus far. First, we will begin by using the def keyword followed by the name of the class, def employee. Next, we know that this class will be inheriting functionality from the person class, so we will attempt to make use of a parenthesis and we will place the name of the appropriate superclass from which the employee subclass is inheriting within these parentheses. After closing the brackets, we make use of a colon. Now, we will construct the template of the employee subclass. It is the first time we are seeing how to construct a subclass which is inheriting from another class in Python. It is interesting to see and is not 100% difficult to understand. First, let's talk logic. We want the employee class to have the same attributes as the person class and a few more. For now, don't worry about those more features. Let us first analyze exactly how we can bring the features from person class into employee class without explicitly hard coding the same things again. It goes as follows. Do you remember the constructor method function that classes have? The init one. Well, if you do, then that's the answer to our task at hand. Essentially, we need to create an init constructor method inside our subclass, and this init method must have names of all parameters for attributes that we would like to have for the subclass. In our case, it would look like this. Class employee person define init self parameter name parameter age parameter emp id. Notice we have three parameters because the employee class will have three attributes. The next question is, how will these parameters receive arguments? Especially the first two because we are not recoding the code. You see, in the next line of code, we need to make use of another init method. Specifically, we need to call the init method that was defined in the superclass. We would do so as follows. Class employee person define init self parameter name parameter age parameter emp id person.init self parameter name parameter age. I hope you still remember about the self parameter that we need to pass constructor functions. Think logically here. The init method that we see defined in the employee class is actually the constructor method for the employee object. The employee init method will require us to pass in three arguments to create an employee object. These arguments are name, age, and employee ID. Now, as we said before, it's ridiculous to have redundant code. Therefore, after setting up the information for the current class, we proceed to call the init method from the person class within the init method in the employee class. What this tells us is that when an employee object is created, a user will provide three pieces of information. Then, the first two out of those three pieces of information will be obtained from the person class setup because the constructor function in the employee class calls the constructor function from the person class so that we can set up values for attributes that are common in both classes. But we have only catered for 2 out of 3 parameters, so we may proceed to set up the third parameter, employee ID. This field is unique to the employee class. The person class does not have it, so we need to set up an instance variable inside the employee class to hold the employee ID field. It would be done as follows. Class employee person define init self parameter name parameter age parameter emp id person.init self parameter name parameter age self.employee id is equal to parameter emp id. You see in the third line of code in the image that says person.init self parameter name parameter age, These parameters are the parameters from the employee init method that are being propagated to the constructor function init method of the person class. Self.employee_id is equal to parameter emp_id tells us that the employee class will have an instance variable for its objects that is called employee ID. This instance variable will store the value that is passed to the parameter emp_id parameter. I really do hope that this makes sense to you, even if just a little bit, because I mentioned before in the tutorial that these are all advanced topics of Python. So definitely things will make more sense to you the more you look at code and work through examples. Back to the explanation. You see, when the person init method was called, this tells us that indirectly a person object is being created in Python and is being coated with a completely new layer of code called employee. Logically speaking, you may think of inheritance like that. So what I am trying to imply is that when the constructor method of a superclass is called, the subclass will automatically inherit all methods within. So essentially, I mean that the employee object will also be having a birthday method. So now, in our new and improved and still a work in progress employee class, we only have one more task to do. We need to set up the calculate total pay method. We do this as we have created any other method in Python. You will find it easy. So we would end up with something like this. Three parameters including the self parameter. Define calculate total pay. Self parameter number hours worked param pay per hour. Self dot total pay is equal to parameter number hours worked multiplied by parameter pay per hour. Return your pay for the day is r plus string self dot total pay. As an extra note, I do hope that you are not getting intimidated by the code in any way. The code is not as long as it seems. It looks that way because of my variable names. I am trying to use long and simple variable names to allow us to see how the data gets propagated and passed from one class to another, and how the data is propagated through a class. And looking at the previous slide, I assume that we understand the way in which the calculate total pay method works. Essentially, when this method is called, you should provide a value for two parameters, the number of hours that was worked in a day or month or such, and then the pay per hour. And by default, I am returning the total pay in rands. So as a simple challenge for you, you could maybe input your parameter argument in your local currency, and inside the method, you could convert to rands using the exchange rate between rands and your currency. A little bit of maths will be used here. And believe it or not, we have actually created a subclass in Python using the principle of inheritance. Full code is as follows. So let us reach a few conclusions about our classes. Number one, we have a class employee which extends functionality of the person class. The employee class base functionality from the superclass. Number two, inside the employee init method, we called the init method that was defined in the person class. This allowed for whatever processes and data within the person class to be set up within the employee class. Number three, all instances of the person class have a name attribute, age attribute, and a birthday method. Number four, all instances of the employee class will have a name attribute, age attribute, an employee ID attribute, and a birthday method, and a calculate total pay method. Excellent. Important inheritance terminology. The terminology that revolves around inheritance is the same as what we have been dealing with all along. Class, subclass, superclass. These are three main terms. One more is called single or multiple inheritance. This term basically states that a subclass in Python may inherit from one or more superclasses. When a subclass only inherits from one superclass, it is called single inheritance. When a subclass inherits features from more than one superclass, it is called multiple inheritance. The object class and inheritance. This is extra information that is very interesting to know. It is a fact in Python that every class that is created extends one or more superclasses. This is true for the simplest of classes. As an example, class person define init self parameter name parameter age. Self.name is equal to parameter name. Self.age is equal to parameter age. The simple person class that we see on the previous slide is actually a subclass. This is because in Python, when a superclass is not explicitly stated, Python will automatically add a built-in class called object as the parent class. Therefore, making your class the child class and the object class is the superclass. This is also the reason why we say that literally everything in Python is an object or instance. In actual sense, the true definition of the person class looks like this. Class person object defined init self parameter name parameter age. Self.name is equal to parameter name. Self.age is equal to parameter age. Every and all classes in Python will inherit from the built-in class object in Python. This means that all behavior that was defined in the object class by the developers will be available for all classes that we define. The built-in object class in Python. The object class in Python is the superclass base class from which all classes arise. Therefore, all classes inherit the functionality that comes with the object class. Do you remember the special methods that we have worked with thus far? Those methods that had a double underscore before and after the method name, such as string. In actual sense, these special methods arise from the object class. These are called special methods or intrinsic methods. Examples of special methods include the string method, the init method, the EQ method, the hash method. Special attributes are also included, such as the class method, the dict method, the doc method, the module method. What is the purpose of subclasses? This is extra information, but information is useful. Any information is good to know. So why have subclasses in programming languages and object-oriented programming? You see, subclasses are used to refine or add onto the behavior and data structures of a superclass. The parent class may offer some functionality which comes in the form of generic, general attributes and methods, and it is these that form the base of the class type. Subclasses are able to inherit these base features as well as add onto and bring their own specific attributes and behaviors. The principles of Python state that there are a selected number of things that a subclass should be able to do when compared to its superclass. It is said that if your subclass does not meet any of these requirements, then you have not chosen the correct class to be your superclass. Your superclass is inappropriate. Ideally, a subclass should modify the behavior of its existing parent class or build on the data that is able to be held by the parent class. This modification should refine the superclass in one or more of these ways. Number one, changes to the external protocol interface of the class. The subclass should extend the set of methods or attributes provided by the superclass. Number two, changes in the implementation of the methods. The subclass should bring about a change in the way in which the behavior provided by the subclass is implemented. Number three, the subclass should exhibit signs of additional behavior that points to behaviors that were inherited.